Hello everyone, how's it going? Today we're looking into smile detection using hard cascades in Opencv on the web. So we'll see how we can develop this. This is based on my previous video on face detection. I will put the link in the description so you know where we are getting these codes from. So let me open up the folder right here for you. Now this is basically the face detection code that we already have in our system, and we are just going to be using and making a few changes in this camera.py file. So this is a camera.py file, which is basically has all the code that takes the image from the webcam and then displays it on the browser. So we're going to make a few changes in that. It was previously designed only to do face detection, but now we will make a few tweaks in it so that it can also do smile detection. So let's open up this, and I have it right here. So this is the camera.py application, which is right now only able to do face detection. Like this is the hard cascades that was designed, or that is capable of doing face detection, but at the same time we also want to do some smile detection as well. So for that purpose, let me find the smile detection hard cascade file. I have it in one of the folders here. So I'm on the other screen right now. I'm just quickly opening up to find the hard cascades for smile detection, because those cascades have all the training files available for doing smile detection. And let me quickly open that up. So I have this here. I got this. So I'm coming back to the main folder now, and here we will paste it. And you would be able to find these files in my GitHub repository, which will be here in the link in the description below. And if you guys are also interested in the other parts of the code, do leave me a comment and let me know what is it that you're looking for, and let me know what kind of a project you're also looking into working into, so that'll help me understand what kind of projects work out for you guys. So I have this hard cascade smile detection, and we will use this to do our smile detection in the camera.py file. So let's open up this camera.py file, and let's make up, like, we have this cascade classifier made for face cascade, which is able to do face cascade detection. Similarly, we will do smile cascade, and we will initiate there's another cascade classifier, same way like this one, face cascade, and instead of cascade classifier hard cascade frontal face, we will call the name of the hard cascade that we have for the smile detection, which is right here. And let's copy the file name, and let's go back to the code. We have the code here, and we just paste the code and .xml. So that's the file name for the hard cascade, which is for smile detection. So now we have this set up. Let's go back to our code from here on this part. Now we want to do, once we have this face detection done, this is again going back to my previous video. So if you have not watched that, go ahead and watch it, so you'll have an idea of what I am doing. And it's just the previous video where we do face detection on the web. So it's a flask application, and this is basically running on a flask server. So once we do the CV2 rectangle where we are doing face detection, let's go and now try to do smile detection on the same image. So once we have the faces, now faces are available on the gray image. Now the gray image is something which has everything. It has my face, it has the background, the body, and everything. We are only interested in the face, because the smile detection is designed only to run on face images. So it cannot, it only assumes that the face that comes to it, or the image that comes to it, is a face and nothing else. So that is why we want to make sure we are removing everything else, and we can do that by using the coordinates of the face that we have right now and removing everything else. So we will create a region of interest, which is also called as ROI, from the grayscale image. So from the gray image, we will only utilize the region where the face is available, and we can do that by providing the image from where we want to do the ROI, and within this brackets you want to supply the information about the coordinates of that area that you are interested in. And we are interested in y, which is the y over here, and y plus h. So if you understand what is happening is you're just taking the information about the y coordinates, and you're telling the y coordinates are anywhere from the top left corner of the rectangle to the bottom right corner of the rectangle. So that is what I am interested in, the y coordinates. Similarly, for the x coordinates, I'm interested in starting from x, which is the which is the top left corner of the rectangle, to the bottom right corner of the rectangle, which is x plus w. So that's the region of interest, where basically the place where your face is available. So here we go. So if you understand here, we are just taking the region of interest from y to y plus h and x to x plus w. That is what the region of interest is basically. Now, like we initialized, or like we detected the faces by using the detect multi-scale, similarly we can detect smile by doing smiles equal to smile cascade, the cascade that we originally initialized here, right here in this section. We're using smile cascade, and we will do the same thing, detect multi-scale. And now I'll go in a little bit detail about what we did. Last time we brushed a little bit more, but I can give you a little bit more information this time. So the first thing you want to provide is the image where you want to do it. In our case, it's going to be the ROI gray. So we'll call it as ROI gray, comma. The next step is to provide this factor, this factor is called as the scaling factor. So you're telling the size of the face is so and so big compared to the other parts, or the size of the object that you're detecting is so and so factor. So it's something that you can always play with. If you're not getting the right output, you can change your values and see if it can improve the accuracy of the system. So it's called as a scale factor, and it's given by scale with a camel scale, and you can put down, in this case, let's try with 1.5. I've tested it on 1.5 and it works perfectly. But in your computer, based on your webcam and based on the background that you are looking at and how far you're sitting on the webcam, your number might differ, so you can always change that. The next thing is letting the system know how many neighbors you have. So the neighbors, how many neighbors you have in your system. You can put down any, just for the sake of let's put down 15 and see what happens. The min size, and this is the size of the window. You're just saying that what's the size of the filter that needs to be run in order to do the face cascade. So these are some of the arguments which the detect multi-scale can take, and you can always change them. If you don't put the values that you want, then it will take some default values. So nothing too much to worry about. So once you have done the detect multi-scale, all the smiles, if they are available in the image, it will be saved in this. And this smiles has nothing but the coordinate, like initially for the faces we had this x, y, w, h coordinate. Similarly, the smiles will also have its own coordinates. So we can always do, if there is a smile, say for I in smiles. So for I in smile, you're just basically telling that how many, whatever smiles they are. If smiles I, or if I is more than 1 or 2, if there are more than 1 or 2 smiles, then you can simply write on the screen that there is a smile. So if len of smiles is greater than maybe 1, so if you see more than 1 smiles, then simply put down a text like we were putting on the browser. On the image, write down a text that the person is smiling. So where do you want to put that? You want to put that down on the main frame, where we are also drawing the rectangle of the face, and we are also sending it to the browser. So this same image you want to write down that there is a smile detected. So you want to put down frame, and I want to write down smiling, and you can say where do you want to write it down, where do you want the algorithm to write down where the application is. So for that purpose, you can say maybe in the same place where this coordinate is, or you can put down, say, just a random place wherever you want the smiling to be detected. So you can, maybe I can put down X, or just a simple value, 30 by 30. Let's put that for the simplicity's sake, comma, and then you want to use a font. So because Opencv, when you're using a put text function, you want to also supply the font that you want to use here. So Opencv has CV2 font Hershey. It's easy to remember this way, font underscore Hershey underscore simplex. So this is the name of the font that you can use. So you're just providing information about the text, and the size of the font would be maybe 1, and the color of the font, let's give it maybe red color or green color. Let's put down red, 255. And you also want to provide the size or the thickness of the font, 3. And lastly, let's put the comma. Lastly, you also want to provide what kind of a font, or how is the text written. So it's written in a line format. Opencv has different types of breakdowns, so you can use different things. So, but we are using a line in order to create that font. So that's done. So this will basically write down the text. If there is a smile detected, it will write down the text called smiling. Okay. So let's save this. Let's go back to our command prompt and let's try to run this. And we have this application. So I already have this running. Let me open another browser and let me close this. And at the same time, let me close this and open up my command prompt. So I'm going to open up another application, smile detection on the web. Smile detection. What is the folder name? Let me find the folder name. I have too many folders created with the same application. Smile detection on web. So that's the folder name. Let's go into that. Smile detection on the web. So we have it here. And if you look into all the files that are available, we have the frontal default XML, har cascade main.py, and the camera.py. So let's run this. Python main.py, and it shows that it is running, and it's running on the port 5000 on the local host. So let's open up the browser once again, and let's type localhost 5000 underscore 5000, and it is now reading it's trying to fetch the video. So it looks like it's fetching the video, but there could be an error, and yes, there is an error. Let's see what the error is. It's saying min neighbors is an invalid keyboard argument, and that is probably because I did a typo in that. So let's go back to our code and the min neighbors spelling, only if I knew my English well. So the spelling of min neighbors is GH neighbors. Yes. So let's save this back again. And let's open up the browser. So it looks like it's running back again now. And the browser once again. Or maybe we close this and open up another localhost terminal. So now it's able to detect and it's able to read my face. It's able to see whether I'm smiling or not, even if I'm purposefully smiling. So it's showing that word smiling on the top left corner, which is nothing but the 30 by 30 coordinate of the image. So this is basically what smile detection can do. It's a basic application just to show how we can do Opencv on the web, and in the next few videos we'll try to do some more complex applications. And these projects, these small projects are helping us laying that foundation, which will help us in creating those much more complex applications. So if it's something that is helping you, if it's something that you're interested in, and it's helping you grow, do let me know, and let me know what kind of projects you are interested in, what you are doing. Leave me a comment. Even let me know what kind of projects you are interested in, what are you working on, and what are you trying to grow into. So that'll help me create my projects and make the channel in that direction. So with that, you guys take care, stay safe, bye bye.